All right, guys. What we're looking at today is corresponding angles and sides. So when we look at this first one here, the corresponding angles are going to be the angles that are congruent between the two triangles. So any angles that are the same measure or are congruent would be corresponding. So if we look at these two triangles here, angle A and angle D would be corresponding because they are congruent to each other. And we know that because of the single mark inside the angle, because the number of marks will match up to the angles that are congruent. So since A and D both have 1, they are congruent. C and F have 2, so they are congruent. And then B and E have 3, so they are congruent. The same thing is true for the side lengths. So when we look at the two triangles, CB has 1 mark, EF has 1. So BC and EF would be congruent. BA and ED have 2, so they're congruent. And lastly, AC or CA and DF or FD have 3, so they are congruent to each other. And because of this, we can actually say that these two triangles are congruent to each other, because we can see that all of the angles, each angle matches up with an angle in the other triangle. Each of the sides are congruent. So we can actually say that these two triangles are congruent to each other. And again, we've named triangles before, but we'll go over it here again. Whenever we name a triangle, we start off with our triangle marker, and then we pick a vertex. So let's start off with triangle, this one here. So we need to pick one of the vertexes, A, B, or C. So we can start off with B and then go to, and then C is congruent. So we started off at B, went to A, and then went to C. And what we're writing is the congruency statement. The way we named the first triangle really does not matter, because we could have named it BAC, BCA, ABC, ACB, CAB, or CBA. Any of those 6, one of those 6s, we just need to name it. Now the second one matters because we have to go in the same order. So what angle did we start with? What is the corresponding angle to B? So we're going to have to start off with E. And then where do we go next? And then, because we went from B to A to C. So here we're starting off at E. Well, we went from B to, what angle corresponds with A? D. And then we go in the same direction. It has to follow the same patterns because it's telling us these parts match up. That B and E match up, A and D, C and F. And it's actually pretty interesting because if we follow along, because BA, we went from B to A, so we have line BA. What did it match up to? BA matched it up with, what are the first 2 letters? ED, which is still line DE, yes? Well, then we have AC. AC matched up with DF. It will tell us all of the corresponding parts because we have to name it in this matching order. Questions on this here? Looking at these two triangles, we want to name the corresponding parts, lines, and angles, as well as giving the congruency statement for the two triangles. So looking at this here, what angles would be congruent to each other or match up? Angle K would be congruent to angle S. What's another set? Angle L would be congruent to angle R. And lastly, J and T. Because we can see it by the little marks inside the triangle. Since K has 3, it's going to match up with S because it has 3. L has 1, R has 1. So they would match up. And lastly, J has 2 and T has 2. Okay. They gave us the angles. Let's name the sides. JL would be congruent to RT, because both of these lines have 3 of our congruency markers on them. They match up. JK and ST, because each one of those has 1. So they are congruent. They correspond to each other. OK is congruent to SR. So those are all of our corresponding parts. For our angles, we need the angle markers. For our lines, or our sides, we need the line segments because they are line segments. Any questions on this here before we write the congruency statement for the 2 triangles? We can start with either one. Give me a vertex on either triangle. J, okay. Where are we going next? And then, because again, the way we named the first triangle really does not matter. We just need to name one of them in a way. So we named one of them as JKL. What is the corresponding angle to J? So the next one's going to start with T, yes. Corresponding angle to K is S and R. Questions on this here? Any questions on anything we've done so far? Okay, we're going to do this again. We want to name the corresponding angles, or the angles that are congruent and the line segments are congruent. And then we want to make our congruency statement. So we can start with angles. Is congruent to, because N and X have how many of the markers? 3, so they are congruent to each other.
Can I have your attention, please? I need Brandon Fowler to come to the office, please. Brandon Fowler, come to the office.
M and Y. Because again, we're matching up those angle markers. Because the ones that have the same number of angle markers will be congruent to each other. So we need sides. MP would be congruent to ZY or YZ, because we can have them either way. It still works. We need 2 more line segments. XY is congruent to MN, because they both had 1. Is congruent to NP. Have we named all the congruent sides and all the congruent angles? Do all of the sides of both triangles match to a sides with the other? Because for each side on the one triangle matches with each side on the other triangle. So we can say those are congruent. Do all of the angles match up? At least one angle in each triangle matches with the angle in the other. So everything in one of those triangles matches with everything in the other. They are the exact same, so we can say that they are congruent and write our congruency statement. So triangle what? MNP is congruent to So we started with M, yes? Y, and then X, and then Z, because the angle that corresponds with M is Y. The corresponding angle to N is, oh, I've screwed up a little bit more, is X, and P matches up with Z. They're going to be in the exact same order. And it's also mainly, we're just lining up the angles that are congruent and following the pattern. Any questions on this here? Let's use this property of what we just learned. Now, we know from a corresponding statements, here we have in the diagram, DEFG is congruent to SPQR. So it tells us what lines up because that order matters. Because since I started with D, well, I know that angle D is going to be congruent to which angle? E is going to be congruent to P. F would be congruent to, because F matched up with Q. And lastly, G would match up with, well, that also means that DE would match up with SP. EF would match up with, GF would match up with, and our last sides would match up the same. Because those are going to be corresponding parts. The corresponding parts are going to be congruent to each other. Now, once it's defined the value of X and Y, well, if we look at the figure with X, so it tells us that the side length is 2X minus 4, yes? Over here. Well, what does it correspond to? GF, which has a side length of? So we're saying 2X minus 4 is equal to 12, because those two side lengths are congruent. If the side lengths are congruent, they have the same measure. So we can go on and solve this for X. What can we do first? Add 4 to both sides, because we do need to get X by itself. Because negative 4 plus 4 will cancel out, leaving us with 2X is equal to, we would divide both sides by 2, telling me X is equal to so we got the first one. Now we need to find the value of, where is Y in the figure? So we have 6Y plus X, and that's defined for what? Q, yes? What angle does Q match up with? 68. So 6Y plus X is equal to 68. Because again, corresponding angles are congruent. Well, we don't know what the value of Y is. What's the value of X? 8. So we can actually plug it in. We couldn't solve for Y first because we don't know the value of X. Now, you haven't finished geometry yet, but in Algebra 1 or 8th grade math or in middle school, did you ever solve for 2 variables at once? Because, I mean, you did systems where you had X and Y, but to solve it, you had to find the value of X first and then find the value of, you had to solve for one, then find the other, yes? In geometry, we'll never solve for 2 at once. And what I mean by that is, 6x plus y equals a number, we can't just immediately find that, because there is an infinite number, or there's a ton of different possible ways we could actually solve that, depending on what the value of x and y is. We need more constraints than just that. Now, we did have the other equation, 2x minus 4 is equal to 12. Well, we solved that and found the value of x, yes? Okay, well, now that's restricted what y can be, because x has to be 8. We will only solve for one at a time. Now we just need to find the value of y. Well, what can we do first? Subtract 8 from both sides, which tells us that 6y is equal to 60. Last but not least, we would and that's it. Questions on this here? Questions on anything we've done so far today? All right, so we're going to do this again. We need to find the values of x and y. It would be helpful to figure out where they matched up. Now, we can do the angles, but as we saw in the last one, it's a little hard to write the angles in. Let's just do the sides for this one and see if that does help. So it's going D, E, F, G is congruent to Q, M, N, P. Now, we know that the order of this matches, that they're going in the same order of what's congruent. So what did it go from D to E? So this segment would be the same as Q to M. Those two would be the same, yes? Then we went from E to F, and then this went from M to and we could start doing that there, because again, it's going to trace around the entire figure in the same order. Because once we get the first two, Q to M, M to N, 1, 2, 1, 2, we'll have to have 3 and then 4. It has to go around the figure, because we had 1, 2, well, the only direction we can go is this way here to finish the picture. Questions on how we got this here? Now, this also means that the angle between the line with 1 mark and 2 would be congruent on the other figure for the angle that's between the line with 1 mark and 2. So if we looked at that there, that would be E and M. Let's see here, E came second, M came second, so those are congruent, yes? The angle that's between 1 and 4 would be angle D, yes? On the other figure, which angle is between the line that has 1 mark and the line that has 4? Wait a minute, D and Q. They will line up still. So if we know that, so we do have two equations. Let's go on and write them out so we can solve them. So I do see that MQ has a length of is x minus 2 and 8 are corresponding lengths, so their measures are congruent. They're going to be the same. I do see that we do have y for angle P, and it is 3x plus 2y. Now we need to find its corresponding angle. Because it's between the line with 3 marks and the line with 4. 3 and 4 would be 84. We could also look at the description. So we're looking at angle P. Well, it lines up with angle G because it's less. P and G, G is 84. Looking at these two equations, which one do we need to solve first? X minus 2 is equal to 8 because how many variables do we have? The other equation has how many? 2, 3x plus 2y. We have to solve for the value of x first. We're going to solve the equation that has one variable first. So x minus 2 equals 8. What can we do first? We need to add 2 to get x by itself. And that tells me x is equal to. We got x by itself, so we're done. Any other questions on this here? Well, that means I can come over here and plug in 10, 4. So we're really saying that we have 3 times 10 plus 2y is equal to, what is 3 times 10? 3 times 10 is what? 30. I don't know why I heard something with an 8. So we don't have any like terms, so we can get y by itself. What is the first thing we can do? Subtract 30 from both sides. Because 30 minus 30 is 0. So we have 2y. 84 minus 30 is? Divide both sides by 2. And that's it. That's all we have to do for this here. Bless you. Any other questions on any of this here? Any questions on identifying corresponding parts or finding the missing measure using the corresponding parts? We feel good with this here? In the diagram, we need to show that P, TS is congruent to R, T, Q. If two triangles are congruent, then all of their parts are congruent as well. We need to know all the sides and all the angles are congruent. Well, from this here, can we say that all the sides are congruent? Because we can say that PS is congruent to QR. The figure shows us. PT is congruent to RT. They are congruent. And ST is congruent to QT. So we do have all the sides congruent to each other, yes? And we know that SP and QR are congruent, or not congruent, or parallel, because of our arrows. Now, angle PTS is congruent to QTR. Why can we say that? Because they are. Why can we say that those two angles are congruent? P, T. Well, I put them there, but there's P, T, S. Q, T, R. What are those two angles? Vertical angles. Vertical angles are congruent, yes? So we can say that these two angles are congruent because of vertical angles. Angle P is congruent to angle R. I'm going to put those angle markers back here in a second. So this angle here Those two angles would be what? Because we covered them in last chapter. Alternate interior angles, yes? Because these would be alternate interior angles. Well, wait a minute. Can't we set that the same way with S and Q? Because they're alternate interior angles as well. So can we say that these two triangles are congruent? Yes, because we can show by the fact that the two lines are parallel that P and R, S and Q are both going to be congruent. P is congruent to R, S is congruent to Q because of alternate interior angles. PTS and QTR are congruent because of vertical angles. So since we know that all three sides are congruent because they gave it to us in the figure, and we can show that the three angles are congruent, then we can say that these two triangles are congruent to each other. Questions on this here? Triangle congruency is reflexive, symmetric, and transitive. Reflexive. Well, triangle ABC is congruent to triangle ABC. It can be congruent to itself. Symmetric. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And we also have the transitive property. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. Well, those are the same properties we had before, isn't it? Because transitive property, if A is equal to B and B is equal to C, then A is equal to C. This still holds true. And again, when we went through, or when they originally went through these proofs, they had to show it. Because just because something works in one situation or one case does not mean it will always work in that exact same setup in that exact same way. Yes? Well, most of y'all play football in here, yes? Just because a play worked last Friday night, does that mean it'll work against the same team later? Well, no, it could, but if we can show that it works every time, okay, then we can say it's a theorem. We've proved it, it works every time. But until we're able to show it, we cannot assume that it will. And that's what they're doing here. We know that these three properties hold true when it was equal. Well, then if we can prove it for equality, okay, then we can do it there. Can we also prove it for triangle congruency? Yes. And once we've gotten it proved, then we can move on from there and use it. Third angle theorem. Third angle theorem. Third angles theorem. If two angles of one triangle are congruent to two angles of another, then the third angles must be congruent. Because what do we know about any three angles in a triangle? They add up to be 180 in any triangle. So if these two triangles, well, the measures of B and A is the same as E and D, well, if they have to add up to be 180, C and F have to be the same, yes? Okay, that kind of makes sense, doesn't it? Because let's just say if B is 50 and C is, or an A is 60, because they're congruent, E has to be, D has to be 60, yes? So if these three add up to be 180, 50 plus 60 is 110. Minus 180 gives us, so C has to be 70. Well, it's also 50 and 60, so this has to be. So if two angles in one triangle are congruent to two angles in a different triangle, then the third angles must be congruent. Now this here is pretty big because up to this point, if I wanted to say that two triangles are congruent, we have to have all three sides and all three angles, yes? What did we just reduce? Well, I still need all three sides, yes? But how many angles do I need? Two, because if I know that two are congruent, the third has to be as well, yes? So before this theorem, how many pieces of information do we need? We needed 6. We needed 3 angles and 3 sides. Yes? How much information do I need now? 3 sides and 2 angles. And that's what we're going to start doing, because there are proofs and postulates where we need less and less information to be able to say that the two triangles are congruent. So let's look at this here. We want to find the measure of angle BDC. Well, how many triangles are here in this diagram? Well, 3, but we have 2 main ones, yes? Because we have BCD is, and then we can have as we really have these 2 triangles here. Now we know that ADC, we have 45 and 30. BCD, we have 1 marker and 2. We need to find the measure of angle BDC. We're trying to find that angle there, yes? A has 1, D has 2. So ADC and BCD, do those 2 triangles have 2 angles that are congruent? Well, yes. So we can say that the 2 triangles, their third angle will be congruent as well. So angle C, the whole angle ACD, is this over here. We can call it X. But what do we know about these 3 angles here? They add together to be 180. So we say X plus 30 is equal to 180, exactly. 45 plus 30 is what can we do? Subtract 75 from both sides, which tells me X is equal to 105. So this angle, well, for this one here, C or ACD is 105, which means it corresponds D or BCD. So the measure of angle BDC is, and it's 105 degrees because its corresponding angle was also 105 degrees. Questions on this here? Find the measure of angle P. So do we have 2 angles in one triangle matching to 2 angles in the other? So the third angles must be congruent, which is telling me that B and P will be the same. They will have the same measure, yes? Because C and Q are 90, so they would be congruent. Is equal to? Well, 52 plus 90 is 142. We can subtract 142 from both sides, because these will cancel, telling us X is equal to. So the measure of angle B is, which means the measure of angle P is because those angles match up together. Any other questions on any of this here? Let's look at the last one here. Find the measure of angle DCN. Well, they only gave us one angle. They gave us the measure of angle D is equal to the measure of angle S, yes? Is there another set of angles that are congruent between these two? Well, do we have any markers on C and R? No. So at this point, we can't say they're congruent, but there is another angle that is. D in C and R in S, because those two angles are what? Vertical angles. Vertical angles are always congruent. If they're setting a figure up like this here, they're hinting at the fact that the vertical angles are congruent. Well, now do we have two angles in each triangle that are congruent? So now can we say that DCN, or angle C, is congruent to RSN, or angle S? So what is the measure of angle C? Or R, because it should be 75 degrees, because it should be DCN and NRS. Those are congruent because they are the third angles. There's 1, 2, 1, 2. So these here are the third. Yes? Okay. I know that there's one last question on this here, and we're going to finish this out with it. What additional information is needed to conclude that the two triangles are congruent? Do we have all the angles covered? Well, yes. Because of the third angle theorem, and they told us that 1 and 2, we have those, we can say that those three angles are congruent. What are we missing? The sides. Right, so what sides would be congruent? We would need that DC is congruent to RS as well as DN, because it's the only other side in that figure that's not, is congruent to NS, yes. Because if we had that, then we can say that the two figures are congruent, yes? But we're still needing 5 pieces of information. We will get to the point where we only need 3. And that is it for today. Your homework is on page 219, 3 through 10, 13, 14, and 17. 17 is one of the error detection problems. And how many pieces of answers are required for an error detection? 2. One is that you need to explain what they did wrong or what is incorrect in their statement. And the second part is to what? Fix it. Actually answer it based off the given information. Because they had one from last chapter where it gave us the two slopes and they said that they were perpendicular. Well, it worked out they were actually neither parallel nor perpendicular. So we need to be able to answer that there. Tomorrow we will be covering chapter 5.4, isosceles and equilateral triangles, and going over their properties. Monday will be a pop quiz over 5.1, 5.2, and 5.4.